One of the fundamental capabilities of the Osprey Pro system are the browsers. Browsers allow you to gain access to the trended and event data that are stored in the database. We start by navigating to our Viewer tab. From here, we select the Trend browser. The first selection we need to make is the time frame. As you can see, we have the option of setting the time frame specific to the number of days, weeks, or months. We can also choose the period that we want by selecting the start date and subsequently selecting the end date. This will be done all the way down to the exact time of day. Now that we have our time frame, we can plot the graph on our canvas. The first step is to create the line graph. For this demonstration, we will select the main ESCOM supply point and take a look at the power associated with it. We can also customize the subset of data by adjusting the variance, the direction, and the number of channels. The color of the graph and the line type can be changed to fit our specifications. The graph is now plotted. What if we wanted to compare the power of the existing measurement point to that of another? We can do that by following the steps we did previously. After line graph, we can select the second measurement point, which in this case will be main ESCOM 2. Once we complete our selection and plot the graph, we can see both points displayed on the same canvas. Otello provides the ability to reposition our graphs by dragging and dropping them to the location of our choice. We can make the use of additional features by clicking the wrench icon found at the bottom left corner. This will display a toolbar that allows us to toggle the title, the values, and the legend of the graph. Furthermore, the data can be exported in a PNG, SVG, or CSV format, allowing us to easily generate papers and technical reports within seconds. The Scatterplot is a useful representation of data that we can add to our canvas. Let's go ahead and create one on the main ESCOM measurement point, with the active power and power factor selected. If we want to view the Scatterplot in isolation, we can simply close the other graphs we have open. The next feature that we can demonstrate, and one that is unique to Otello, is the harmonic spectrum. When investigating harmonics, your primary indicator is the total harmonics distortion. Before introducing the harmonic spectrum, we first need to create the line graph to contextualize the data. Let's go ahead and make one for Klutzville that showcases the voltage distortion. With the graph plotted and the 3 channels displayed, we can bring in the harmonic spectrum. We will need to replace the selections we have made for our line graph to ensure the 2 datasets coincide. After a brief moment, the browser will query all 64 harmonics and interharmonics simultaneously and display them below. The graph can be resized by dragging the connecting line up and down. Above our canvas, we have 2 sliders. The first slider controls the rate and animation speed, while the second is a cursor that allows us to navigate through our timeline. Once our sliders are in place, we can pick the play button and begin the animation. As the cursor moves through our timeline, we can see that the harmonics are constantly changing. As the voltage distortion graph fluctuates, so do the corresponding harmonics. To better analyze a specific point in time, we have the option of zooming in on our line graph and dragging the cursor to that instance. The harmonic spectrum provides a great boost to productivity and efficiency by simplifying the process while maintaining pinpoint accuracy. Let's take a look at one of Otello's other capabilities. Once a selection for our measurement points and data stream is made, we can make use of the Help button below to provide additional information about function plotting. This window gives us a brief description on how it works, the correct syntax to use, as well as a few examples to give us a better understanding. With the help of Java, any mathematical function can be added to our canvas for our convenience. Let's go ahead and copy the return x0 plus x1 function shown. We can add this to our canvas by clicking the Advanced button and pasting it to the available box. Once we go and plot the graph, we can see our data streams as well as our new function represented simultaneously. The Trend browser's intuitive display of information provides grid engineers with the tools that they need to manage the grid proactively, with accurate real-time power performance data to make confident and informed decisions.